Okay, so we're now going to have a look at just using vectors for another kind of thing that we've got here. So it's for the area of a triangle. And actually, I think you probably have done questions similar like this in some of the earlier exercises. There was one homework question a few weeks ago that was like this. But I just wanted to do a final example to make sure that we all had this in our notes. So we've got here the area of a triangle is what we're trying to find. It says that the vector AB is equal to this and AC is equal to this. Determine the angle BAC. So that's the first thing it's wanting us to do, is determine the angle BAC. So the strategy that I've said we're going to use here is we're going to find three lengths of the triangle, and then we're going to use the cosine rule to find the angle that we have there. Okay? Now, I already have here, I've drawn a sketch of this triangle, but obviously if you didn't have that sketch there, you could have just drawn any triangle and labelled the points A, B, and C. And weirdly this time, they haven't told me the position vector. They've instead told me something different. They've told me the vectors of the sides of the triangle. So they've told me how to get from position A to position C and from position A to position B. Now, in order to find the three lengths of the triangle, I need to find out what the vector CB is. I need to find this third side of the triangle as a vector. So how do you think I could find the vector from C to B?
From CA to AB.
Good. If I want to go from C to B, I can go CA and then AB. So we're just doing different pathways around the triangle here. So to go from C to B, I can go from C to A, and then I can add on from A to B. Now, I actually don't know what CA is, but I do know something that's similar. I know what AC is. How is CA related to AC, Jamil? So, yeah, we would say it's the negative of it. It's not the reciprocal, just the negative. So it's negative AC plus AB that we've got here. And you could either write that the other way around as AB minus AC, but I actually think we can just go straight in with what we've got as the information. So I haven't written these in column vector form yet, so I might just quickly underneath jot that this one is 3 minus 2, and this one is 1 minus 5 that we've got here. So the negative version of this, that's going to be minus 1 minus 5, plus AB, which is 3 minus 2. So that's minus 1 plus 3, which is 2. And then minus 5 minus 2. What's that?
So plus 5 minus 2.
Plus 5 minus 2, which is 3. So now we can go back to here, and we can say that the side of this triangle is 2, 3. And because we're trying to find out what this angle inside here is, we said that we're going to use the cosine rule. But the cosine rule is to do with the length of the triangles, the sides of the triangle. So can you just remind me how I find the length of one of the sides of the triangle? Khadija? You find the magnitude of them by using Pythagoras. Yeah, so I'm going to just really quickly find the lengths of these sides. So I could say that AB, notice how I'm not saying it's a vector anymore, I've just got it written as 2 letters, would be the square root of 3 squared plus 2 squared, which is
13.
root 13. Then I'm going to say that AC is going to be the square root of 1 squared plus 5 squared, which is root 26. And then I'm going to say that the length CB is root 2 squared plus 3 squared, which is also root 13. So what type of triangle have we got here? We've got an isosceles triangle. Okay, we have an isosceles triangle. It doesn't look like an isosceles triangle because I didn't know what it was going to look like just from the vectors that were given to me. And we do the cosine rule again in year 12, but I thought it would be useful still to look at this because it does pop up in GCSE, but I know we had a bit of a different end to the GCSE year. So we're going to use the triangle. I'm going to draw out the triangle again because sometimes I find that triangle has too much information on it. And I'm just going to label the sides. So we said this is A, B, and C. Okay, so AB was root 13, CB was root 13, and AC was root 26. And we're trying to find out this angle that we've got up at the top here. So for the cosine rule, the angle and the side are opposite each other. So this is the angle A, and this is the side A. And it doesn't really matter which one is B and which one is C. But in this case, we normally say the side opposite B would be B, and the side opposite C would be C. So we're going to use the cosine rule that we've got here at the top, okay? So it says, and I'm going to substitute everything in first. I'm not going to rearrange it. Sometimes people like to rearrange it to make cos A the subject. Personally, I just like to substitute everything in and then to solve the equation and find out what the angle is. So A squared is root 13 squared, which is obviously just 13. B squared is this one, root 26 squared, which is obviously just 26. C squared is just going to be 13. And then here we've got minus 2bc cos A. So that's minus 2bc. So that's root 26 root 13 cos of A. And A is the angle that we're trying to find. So if we just do a little bit of simplifying that we've got, so 13 equals 39 minus, I'm just going to grab my calculator. So you've got 2 times root 26 times root 13 minus 26 root 2 cos A. So when I rearrange this, I've got 26 root 2 cos A equals 39 minus 13, which is 26. So cos A is, what do I need to do to both sides here? Divide it by 26 root 2. And then to find out what A is, I will do the inverse cos of 26 over 26 root 2. Sorry? That's a 26. Which is, grab your calculators. Okay, it's 45 degrees. Is there any space on the back? Nope. So we found out what the angle was 45 degrees. Now, it doesn't actually, I forgot to add this into the question, but what I'm going to try and do, if you can squeeze it in, is I also want us to find the area. Find the area of the triangle. How do you think we could find the area of the triangle? Okay, so we're going to do that one first. We're going to do a half AB sine C, and then I'm going to see if anyone can spot a different way that we might have been able to find the area of this triangle that we've got here. So we're going to try and find the area using a half AB sine C. So that's going to be a half times by, in this case, do you know how AB sine C works? Yeah? Lily, how does it work? It's the two sides adjacent to the angle. If you're not so sure about some of this, we do go back to this later on in the year. So if you're finding this a bit like, oh my gosh, I didn't do this in GCSE, we do it later on in the year. So in this case, this angle we've just worked out was 45 degrees. So it is just going to be a half times by the two sides either side, which is root 26 times root 13 times sine 45. And we're just going to get that into our calculators and see what the answer is. So that's a half times root 26 times root 13 times sine 45. And we get the answer, a rather nice answer, of just 6.5 units squared for the area. But that was only one of the ways that I think you could do this. And I think that one is just using a formula just because we know the formula. I wonder if there was a different way that we could have found the area of this triangle that was probably something you could have done without the knowledge of a half AB sine C. What do you think, Andrew?
Could you do something where you figure out the height of the triangle?
You could do something where you figure out the height of the triangle. In fact, we already know the height of the triangle.
Do you just do base times height and then half it?
Yeah, but do you remember earlier on I said to you, what type of triangle is this? Okay, so let's go back to that piece of information, okay? Let's go back to the idea that we said this triangle was isosceles. And we know that this angle here is 45. So if this angle here is 45, which other angle is 45? This one or this one?
The one above.
Are you sure? No. It's this one at the bottom, because look, these are the same size as each other. So this one here must be 45, because it's an isosceles triangle. So I'm going to draw that sketch again. If this is 45, and if this one is 45, what's this one? 90. So I'm going to draw that triangle again. It's actually like this. It is root 13. It is root 13. This is 45. This is 45 because it was an isosceles triangle. And this is 90. And how do you find the area of that triangle? So the base is, the height is, of course, this is the base and this is the height. They're at right angles to each other. So it's just root 13 times root 13 over 2, which is 13 over 2, which is 6.5 units. So I quite like this example because you didn't need to know about a half AB sine C to do this, just because of this very specific example that we had here. And I asked that question earlier on, what type of triangle is this? Sufyan told me that it was isosceles. And once we found out that the angle was 45 degrees, we know another angle must be 45 degrees, which means the third angle must have been 90 degrees, which means I can just do the area of the triangle is base times height divided by 2. Now, obviously, either of them give you the same answer, but being able to see both of them makes you a better mathematician. And so that's why I wanted to kind of show you that extra way of doing that. So we're just going to try one question of doing the area of a triangle, and then we'll do the last tiny bit on vectors, and then we're going to do our little short assessment, okay?